given in a clear format. Okay, regarding your first unit. Okay, so now we'll be moving on. So try to complete the assignment also in the time. Okay, so now we'll be moving on to the dielectric breakdown. Okay, so the lecture one comprises of breakdown in gas. Okay, we'll be seeing about that. So in this lecture, we'll be seeing the dielectric breakdown in gas. Okay. So next is the different types of ionization process we will be seeing in this lecture. Okay. So I have already said to you. So with an example, that is, if we are standing below a transmission line, okay, there won't be any kind of effect due to the transmission line over you. Why in the sense means the air will be acting as a dielectric. Okay, the air is a very good dielectric medium. It doesn't allow any charges to pass through it. Okay, so but in this gaseous breakdown, what happens is that in order to make conduction in the gas, you have to break its dielectric strength. So the gas will be having some amount of strength to resist the conduction of charges. Okay, the air will be having some amount of strength, which is called as dielectric strength, which resists the conduction of charges. So if the strength is broken, okay, if the conduction of charges breaks the dielectric strength or it goes above it, what happens is the gas will be acting as a conduction medium. Okay, so this is what in general happens during your lightning. Lightning, as we have seen in the previous chapter, what happens is the lightning ionizes the gas. Okay, ionizes the gas to break the dielectric strength of the air. Okay, dielectric strength of the air gets broken. How in the sense means due to the ionized particle of the air. Okay, during the lightning. So with respect to that, after breaking the dielectric strength in the gas, the conduction will be successful and the lightning reaches your ground. Okay, that's what you have seen in your previous unit. Okay, so we'll be seeing with respect to that how the dielectric breakdown occurs in gas. Okay, so followed by the process, what are the process, how the dielectric occurs in your yeah. Okay, so mainly due to the ionization process. So this ionization process includes these 4 points: ionization by collision, photoionization, secondary ionization, and electron attachment process. So these 4 already you have studied in your 12th standard chemistry. Okay, these 4 points already studied in your 12th standard chemistry. You just have to recall it. That's all. Okay. So this is the unit topic. Okay. Okay. First, we'll be seeing with respect to this. So breakdown in the gas. Okay. So in general, the breakdown in the gas is normally referred to as the spark breakdown. In general, it is referred to as spark breakdown. So what it refers to means, it refers to a transition of a non-sustaining discharge into a self-sustaining discharge. Okay, so you have to know the difference between the non-sustaining discharge and a self-sustaining discharge. Okay, so for self-sustaining discharge, the example what we can say is your lightning. The lightning will be coming under your self-sustaining discharge because the ions in the lightning will be increasing in an exponential manner. Okay, so it gets increasing in an exponential manner. So here I have said, right, so here you can see this breakdown is there, right, this Vs and this is breakdown. So this is the breakdown voltage. This Vs here represents your breakdown voltage. So after this Vs only, if the voltage is going above this Vs only, your air or any kind of gas will be starting to conduct. Okay. In general, this Vs varies for each type of gas. Okay. We are taking a container only with nitrogen, and if you're seeing its breakdown voltage means it will be different. Okay. Similarly, if you're taking only oxygen, and if you're taking the breakdown voltage means it will be different. So each gas will be having a different value of its breakdown voltage. But the condition is very simple. The condition is that your voltage has to be above the breakdown voltage. Okay, then only the conduction will be happen. So till that, what happen is there will be non-self-sustained discharge. There will be some amount of discharge, but it won't be having that much effect. Okay. So if it is going to the self-sustaining discharge means only it will be somewhat we have to take into consider have to be more cautious. Okay, because it might be lead to some drastical damage effects. Okay, so in that case you have to be very much cautious. So these expressions and this I equal to I naught exponential alpha d, this and all we will be seeing about this entire diagram we will be seeing in separate derivation in this unit. Okay, at the time I'll be explaining that. So now you have to just know the breakdown in a gas is called as spark breakdown. Okay, that you have it in mind. So next is the primary reason. So you have to know how the breakdown is happening. Okay, so the same process what happens in the lightning. So in your lightning, generally what happens is first there will be charge separation mechanism. So we have studied with respect to the theory, right? Two theories we have seen. Streamer theory we have seen, and another theory we have seen. So with respect to that theory, there will be separation of charges. So after this charges separating, what happens is your air will be ionized. Okay. So your air will be ionized by the negative ions in the cloud. Okay. So when it is ionizing, the nearby ions in the air will also get ionized. Okay, so it will be forming like a chain. The process will be in a chain format. Okay, so the main reason over there is only due to the ionization. So ionization is nothing but that is the breakdown of gas is build up of high currents. Okay, high currents which is mainly due to the process of ionization. So you have to take into the account the mechanism of lightning, what you have seen in your unit 1. Okay. So next we'll be dealing with the ionization process. So what is ionization process? Okay. So this thing entirely you have studied with respect to your chemistry. Okay. So in your chemistry you have dealt with your different kinds of bonding. Okay. In your organic chemistry also you have studied. In your physical chemistry also you might have studied. Okay. Different types of bonding which is followed by your first is your ionic bond. Okay, ionic bond we have studied. Next will be coming with your covalent bond. Okay, so such kind of same procedure only here also it's happening. Okay, so what generally happens is ionization if you are asking me, it's nothing but the process of liberating. Liberating means it's coming out. Okay, either a positive ion will be coming out or an electric negative ion will be coming out. Okay. Okay, from where it's coming? So it's coming from either a molecule, okay, that is it is coming from a stable molecule or atom. Okay, so when you can say atom is a stable or molecule means when it has no ions in it. Okay, so when it is valence electrons are entirely filled. Okay, just remember the 12th standard chemistry principles. Okay, when it's the valence shell is entirely filled up, or it is in the two's power. Okay, that is either 4. It is an even number means the electrons in the valence shell is an even number means will be stable. Okay. So from the stable molecule or atom, you are removing a single uh, electron or a positive ion. The positive ion will be at the nucleus. It will be very difficult for your removal. But your negative ion will be at the valence electron, valence orbit. So it will be very easy to remove. So when this happens, so your atom becomes a charge. Okay. That's the difference. That's the main concept of converting your atom or molecule into a charge. Okay. So this is done by the ionization process. So what are the types of ionization process means? Ionization by collision, okay, that you have already know. Then photoionization, okay, photoionization. Then is the secondary ionization. Final one is your electron attachment process. Okay. Okay. So we'll be seeing about these four things in this lecture. Okay. So we'll be moving on. First is the ionization by collision. So this is the normal conventional ionization process. So if they are saying ionization process means by default they will be indicating this mechanism. Okay. So what they are saying here, in the process of ionization by collision, okay, that is in this process, a free electron, which I said right, a free electron E minus collides with the neutral gas or molecule. What I said in your previous slide, the same mechanism they are saying with your diagrammatic representation. Okay. If an electron gets bombarded with the atom which is stable or a molecule which is stable, in general, what it gives rise is to a new electron. Okay, so here it liberates new electron and a positive ion. Okay. What happens in general is it just splits this atom, stable atom, into a unstable ions. Okay, these ions are unstable. Okay, why it's unstable? If the positive ion is coming near to this negative ion means it gets attracted to that. Again, if a negative ion is coming towards this positive ion means it again gets attracted. So these ions are dynamic in nature, whereas this atom is in uh, stable state. Okay. So this is the process of ionization by collision. Okay, how you can ionize the air, okay, by the process of collision. Okay. In general, what we'll be having is you have to consider low pressure gas column. Okay. So here they are taking two electrodes, anode, which is your positive, and cathode, which is your negative, and these two electrodes are connected to a source. Okay. Connected to a source is nothing but a battery. Okay. It is connected to a source. So for limiting the current here, they have given a system. So this is not the part what we need. Okay. So what they are saying is, and this setup is made at a low pressure gas column. So when you are making it in a low pressure gas column means you have to go to the gas law again, which will be in your physics, sorry, chemistry. Okay, so in gas law, if you are seeing means PV equal to NR and T. PV equal to NRT, you have seen the equation. So with respect to that equation, you'll be taking the low pressure. Okay, so it is kept in a low pressure. Now what happens is it's the energy E. So E is the electric field that you are applying. Okay. Gain during this travel between the collision exceeds the ionization potential. Okay. So here what they're saying is, if the applied voltage is more than the ionization potential, so what you have to take into account here is the applied voltage must be strong enough to provide an electron to this cathode. Okay. So applied voltage must be strong enough to provide an electron to this cathode. Okay. So if it is like that, means then only your ionization takes place. Nothing but your applied voltage must be greater than that of your ionization potential. Okay, that's what they're saying. So here, only when this electron gets attached to this atom, only when the condition is your applied voltage must be greater than that of your ionization potential. So ionization potential is nothing but the energy required to dislodge. Dislodge means remove an electron from its atomic shell. Okay. So this is a normal ionization process. So next is the photoionization. So photoionization means what you see, as the name suggests, this will be with respect to your light effect. Okay. With respect to your light effect, the light effect may be either any kind of radiation. It can be ultraviolet, or it can be infrared, or it can be normal light wave. Okay, it can, that's what I'm saying, any kind of radiation. Okay, so what they're saying with respect to the definition means photoionization occurs when the amount of radiation energy absorbed by the atom or molecule exceeds its ionization potential. The same thing. So in the before ionization by collision, what they are saying is that the applied voltage must be above the ionization potential. Here, what they are saying is the radiation what we are applying must be above the ionization potential. Okay? The energy of the radiation. We have to see the change. So, energy of the radiation means H nu is the radiation energy. The H nu value must be greater than the ionization potential, that is E. It's nothing but voltage. Okay. So if the energy is higher, means surely there will be the photoionization takes place. There are several processes by which radiation can be absorbed by the atom. So what are the processes? They are excitation of atom to a higher state. So you might have seen just a minute. Yeah, see over here. So take it like this. So this will be your this will be your conduction band. Okay. So this will be your valence band. Okay. So this will be your valence band, and this will be your conduction band. Okay. So for an electron, okay, for an electron to get conduct, for an electron to be conductor, okay, so this electron must be moved from this valence shell to its valence shell to its conduction band. So here they refers to band. Okay, so it has to be moved from its valence band to the conduction band. Okay, this is the process for conduction. Okay, this is the thing what you have studied in your physics and chemistry, both the thing you have studied. So for this thing, in general, what happens is you have to apply some energy. So this energy is in form of light. Okay? In form of light. Okay? So this energy is responsible for making this to travel from the valence band to the conduction band. So this is your light energy. It's nothing but H into nu. Okay? So this point you have already studied in your physics as well as chemistry. I'm just recalling it. Okay. If this energy is happening, then the electron moves from your valence band to your conduction band. So that's what with respect to your first excitation of atom to a higher energy state. Yeah. The second thing is continuous absorption of direct excitation. Direct excitation uh, of atom or dissociation of diatomic molecule. Okay. So this is another process. Okay. So continuous absorption by direct excitation. So this refers to what means the atom will be absorbing lot amount of energy continuously. It will be absorbing. So in general, what happens is the molecule will be uh, separated. Yeah. So here you can see, just as an excited atom emits radiation, when the electron returns to the lower state or to the ground state, the reverse process takes place when an atom absorbs radiation. So the what I have shown in the previous diagram, the paint, what I have shown was an absorption process. The energy gets absorbed. Okay, so yeah, that's what they're expressed here. So atom, okay, so the atom is exposed to the H nu. H nu is nothing but the radiation energy. Okay, then it becomes the ion. Okay, then it becomes the ion. This process is not only a forward reaction; it is a reverse reaction. It's a bidirectional one. There is possibility of the ion. What I have shown in the paint is also will be also able to liberate the ion and become a positive one. Okay, in that condition, it will be. So this is refers to with respect to a positive, that is absorption. Okay, so there is also a possibility. There's also a possibility for this ion to come to the valence band. Okay. It's just a reversible reaction. So in such case, that is, it becomes exposure. So here it is absorption. Okay, here it exposes the light. So what happens is H nu energy gets liberated. H nu gets liberated. Yeah. So that's what here they're giving. So here they are giving the Legends expression. Okay, that's just Planck constant. Is the velocity of light. Okay. So here what after they are applying, yeah, the constant. So this will be entirely the constant. T is velocity of light 3 in 10 power 8. So H is Planck constant 6.235 into 10 power 23 will be coming out. So after applying those constants, we'll be getting this value. So with this, what you can infer is that the higher the ionization energy, the shorter will be the wavelength. Okay. So your ionization energy, uh, lambda is nothing but this is your wavelength. Okay. So these two are inversely proportional from this expression. So higher the energy, lower will be your wavelength. So with respect to the wavelength, you can decide what kind of spectrum you will be using for the absorption of the radiation. Okay. So here what they're saying is radiation having a wavelength of 1250 Armstrong is capable of causing photoionization for almost all gases. This is a general point. Okay. The next we'll be moving to the secondary ionization. Secondary ionization is similar to your avalanche breakdown. Okay, more or less it will be similar to your avalanche breakdown. So secondary ionization process by which the secondary electrons are produced. So first the primary ionization will be taking place. From the primary ionization, the electron liberator will cause ionization. Okay, it's like a chain. From that ionization, secondary ionization, another one electron will be liberated. So what are the types? So types of this process include electron emission due to positive ion impact. This you know. So how the electron emitted due to the positive ion impact, electron emission due to the photon, okay, electron emission due to metastable and neutral atom. So mainly it will be due to the positive photons, okay, finally the neutral atom. How the positive ion affect? Being positive charge, they travel towards the cathode, so then the ionization occurs. So this and all happens after the primary ionization. After primary ionization, this kind of process happens. Okay. The total energy of the positive ion is greater than the twice the work function of the metal. That is, if the energy of the positive ion is able to liberate the electron from the metal. Okay. So that what I have said is the ability of the positive ion to liberate a negative ion from the metal is the work. Okay, so that work gives out some energy. So that energy must be twice. Okay, that's what here they are saying. Okay. Then one electron will be ejected and second electron will neutralize the ion. Okay. So the probability is measured in OI or Townsend secondary ionization. Regarding this, I will be dealing in the upcoming classes because it is the derivation part, Townsend secondary ionization. Okay. While taking with the derivation part, I will be explaining this. Okay. Next is due to photons. Photons are nothing but light. H nu is your photon. Okay. Photon is the energy, nothing but H nu. To cause an electron to escape is entirely similar to your photoradiation. Okay. First, the ionization process will be taking place. Then again, you will be exposing it to the H nu. Okay, that is radiation. So after that, again the ionization process will be coming into effect. Okay. If the incident radiation has a greater frequency than the threshold frequency, then excess of energy goes partly as a part of kinetic energy of the emitted electron. Okay. So here they are saying how the energy gets liberated. Okay. But the concept is this, similar to photoionization process. Okay. So next is due to the metastable and neutral atom. Okay. First you have to know what is a metastable atom. Okay. A metastable atom is nothing but an excited particle whose lifetime is very large, 10 power minus 3 seconds. Okay. So in general, the ordinary particle will be having a 10 power minus 8 second. 10 power minus 8 second means is very, very minimum. Whereas the metastable will be having some more amount of lifetime. Okay. And what they're saying is electrons can be ejected from the metal surface by impact of this metastable. Okay. So more or less they will be giving with respect to their work function. So with respect to the work function, everything must be larger. Okay. Either the energy, ionization energy, or the energy photon radiation energy, okay, or the energy from the metastable, everything must be greater than the work function of the metal. Okay. So that's what with respect to today's lecture. So tomorrow we will be seeing about the theories regarding this breakdown. So in this they might be asking properties of dielectrics, the book. So then they will be asking process of ionization. So 2 marks we can expect more from these kind of in this lecture. Okay, 2 marks area we can expect in this part. Okay, so that's on the recording with this.